Okay, looks like we're ready to get started. So hey everyone, thanks for coming out to this presentation. It's titled Stylized Shading with SIGGRAPH, but it has recently been retitled into the Shaderverse, and you'll find out why later. So first, I just want to go over briefly what exactly SIGGRAPH is. So who here's tried out Unity's SIGGRAPH? Just raise your hand. Okay, cool. So quite a few folks. So before 2018.1, Unity included a number of built-in shaders. But if you wanted to do something super unique, you basically had to write your shader by hand with HLSL. And that's actually a pretty steep learning curve because it requires programming knowledge, it requires knowledge of shaders and graphics techniques, and a lot of folks kind of just felt quite frustrated by that. So today we have SIGGRAPH. So SIGGRAPH is a visual shader editor. So instead of writing code, you connect a network of nodes together, and you use that to describe the surface of your object. So this method basically allows users with very little to no programming experience to create pretty elaborate shaders. So hooray for SIGGRAPH. But now a disclaimer, even though I just gave all this talk about you don't need to know programming to use SIGGRAPH, this talk will have code. So the main purpose though is more the workflow of how to use custom code within SIGGRAPH, because there are times when what you want to do is unique or special enough that the node just isn't built in that does that. So even though there is code, I would still recommend this talk for technical artists and artists, and you'll get the most out of it if you do have some familiarity of using a kind of node-based shader system. Also, all the code is kind of at the first half of the presentation, so just like stick around, and the second half of the presentation is lots of pretty pictures of graphs. So who am I? So I'm Natalie Burke, lead technical artist on the Seattle graphics team. So in Unity, being a technical artist basically means I'm working to improve pipelines and create new workflows and tools for content creators and other non-technical users. So I've worked on a number of the new features that have been released. And in addition to that, it also means putting together presentations like this, demo projects, just to make sure people are aware of how to best use these new tools. But let's dive into this topic, stylized shading. So we talk a lot about physically based shading and how to author your content best for PBR. And physically based shading is great for for creating work that is believable. But what if your art style isn't based on reality? And that's really popular actually. You see that a lot. So can you still use SIGGRAPH, and how easy is it to use SIGGRAPH? So I also kind of want to define for this talk what I mean by stylized, because it's a pretty generalized term. It could mean a lot. So essentially, in this context, it means it doesn't have to match reality. And we're doing that by exaggerating or removing details to enhance the look of something. And since we're talking about SIGGRAPH, this is by altering the surface's response to lighting and shadowing. So you can also create stylized looks based on how you model your geometry and do your texturing, but we're just going to look at the shader approach. And for this talk, this is the example we're going to walk through how to make. So essentially, this is a comic book style shader. Here's the final results applied to a number of those default props from the template workshop scene. And back to that title, Into the Shaderverse. So I definitely took inspiration from Spider-Man and the Spider-Verse because I love that movie. Seen it way too many times now, but I don't know if you can see it way too many times. But I was just really inspired by it's beautiful. And I kind of wanted to see, can I kind of use this as inspiration, create something of that similar vibe in Unity? So my first steps was looking at this particular scene, and I was like, okay, well, how would I draw this? What were the steps I would take to recreate this frame? So I broke it down into a few various steps. So the first I would think about is my inking and my shading. And then I would kind of want a nicer fall off for that, and I would probably use like a cross-hatching technique to really feather out the shading. Then I would add in my colors, and then I want to add in some of the highlights. So I definitely want like an interesting like specular pattern, so I would probably do a highlight with some dots or some stippling to it. And then I want my characters or my assets to really pop from the background, so I would like a nice like sharp rim lighting. So there's kind of three main steps that I need to go over to achieve this look. So first I'm going to need to create my own custom lighting shader. And that's so I have full control over how my surface interacts with lighting. So then I'm going to need to modify this lighting response by various effects and layer them on top of each other, which is actually pretty similar to drawing. And finally, I want to build a workflow. So this shader is really easy to reuse across a lot of different assets in my scene. So let's get started with step one. Let's create our custom lighting shader. So the first step to create a custom lighting shader is by using a shader with no lighting by default. So this would be our unlit shader. I would also want to decide on a render pipeline at this point. For this particular example, I'm using the lightweight render pipeline. The other thing I'm going to need is this custom function node. So the custom function node was released in 2019.1. And basically with this node, you can define ports, so inputs and outputs, and write custom HLSL function code directly in the node UI. You can also reference an HLSL file and call functions from there. So the first step then to create our custom lighting shader is I need my light data. So I can do that using the custom node. So to use the custom node, you want to click the cogwheel in the top right. And basically inside this menu, you can add your inputs and outputs. So you can see I have my output for light direction and light color. They're both vector 3s. And on the left, you can see how I'm using those by in the custom code. So our custom code is split into two parts by an if-def. The top describes basically what's going to render in the preview box of the graph. And the bottom half is where we're getting the actual light data. So notice we're calling this function getMainLight. Now that's a built-in function in the lightweight render pipeline. And we can use that to assign the direction and color outputs. Now the if-def for our preview box is necessary in this case because the shader used for the previews in SIGGRAPH are not specific to render pipeline. So it doesn't have access to this getMainLight function. It doesn't know about it. So now that I have my light, I basically need to use it. So I just want a very basic Lambert, and you can get that from Googling. I actually went just to the lighting.hlsl file in the lightweight render pipeline and just took a look at the code. So this is the lighting Lambert. And basically, I just recreated that with my new light data of color and direction in SIGGRAPH. So dot product of normal vector and light direction, saturate, which is basically just a 0-1 clamp, and then multiplied by my light color. And if you look at the preview, there's basic Lambert lighting. So remember I also mentioned that it's possible to reference an HLSL file from our custom function node. Now, this is recommended when you're doing more complicated operations, because you can work inside basically your preferred code editor and have a unified location for debugging. So here I've expanded my main lighting function. Now it gets the attenuation values from our main light, but it also receives shadows from other objects in the scene. And since this function got more complicated, I'm going to switch into file mode and use an HLSL include file called custom lighting. Now, we don't need to focus right now on the content of what is in that function. What's important is actually, for this talk, how to use a custom HLSL file. So the first step is make sure the name basically matches the name of your function, but without the suffix. So the suffix tells the compiler which precision format the function uses. This is actually a new feature in 2019.2. So for this example, we're using float, but there's also half precision, and that's useful when optimizing shaders for kind of lower end hardware, mobile. So you can create a duplicate of our main light function with an _half, or the half suffix, And then it would compile, or it would choose which function to compile based on the precision you selected in your custom function node. There is also a color mode now to let you kind of see your precision. So like blue means float and red means half. So you can easily track the precision basically through your graph. So then we just have our inputs and our outputs. And we've set up our custom function node. Now, the next step I recommend is kind of turning it into a subgraph. So right now, the workflow would be taking this custom function node and copy and pasting it in every single shader you want it to be used in. And that's not an awesome workflow. If you make it a subgraph, which just simple as right-clicking make subgraph, you can give it a custom name, and then it is searchable in the Create Node menu, just like a built-in node. And this is also really nice if you need to update it somehow, add a new input or output, because you only need to update it in one location. You don't need to find all the shaders that are using it. So now we have our current basic lighting setting. It's using the new attenuation. And there's our subgraph, nicely named Get Main Light. Now the next step is we actually want our direct specular. And this workflow is exactly the same as what we just went through, so let's just review. So you want to add a new function to your custom lighting file. And that function would then be the one that calculates the specular. So you create a new custom function node, reference your file, fill out the values, so the name, the input, the output, convert to a subgraph, give it that nice name so it's searchable and easy to reuse, and then use it. So for specular, we just want to add that results directly to our final color. So now we have our updated graph with our specular. There's the subgraph. And if you look at the preview, you'll see now it has a specular highlight. So if you really wanted to complete your full custom lighting shader, there are a few more steps I'm not going to be covering. So these would be adding in your ambient lighting and your global illumination. Updating the surface to work with multiple lights. So for the case of my comic shader, I'm only using the Get Main Light right now. And then just more organization, putting everything in those nested subgraphs and groups. Now, don't sweat if you don't even know how to get started with that, because literally this morning a blog post came out that covers all those items. So look up custom lighting and shader graph, expanding your graphs in 2019, check out the Unity blog. It's updated today. There's a sample project with that blog post, different from this, that's available for download. And then at the end of this presentation, I'll show you where you can download the comic book shader too. Okay, enough with the code. Let's get to the fun part. Let's make our surface look like a comic book. So let's refresh ourselves on kind of the look we're trying to recreate. And what we already broke down is like the artistic steps to get there. But we need to convert this into a graph format. And that looks something like this. Now let's overlay our visual pieces so we kind of see better what's happening. So first we want to basically multiply our ink shadows by our cross-hatching. And that gives us our shading. And then we need to color it in, so we just multiply by some flat color. Now we need to add in our highlights. So let's add our specular, stippled specular, and then add our sharp rim lighting at the end. And then you see at the very end, we have our final look we're going for. So for most of these effects I'm going to be covering, I'm leveraging a technique called ramp shading. So this is the ramp shader actually from Maya. So any artist in the room may be familiar with this. But essentially what you can see is based on the brightness or value of our light color, we're sampling that gradient at different points to color in our asset. So if you look at the donut on the right, you can see the difference you get with different light intensity values. So this is how you recreate that in Unity. So first step is we need that output from our diffuse lighting, and it's in red, green, blue values right now. We actually want to convert that to hue saturation value. This is because we want to modify that value or that brightness value of our light and use that to sample into another texture. So for this example, I'm sampling into the gradient editor. I'm using the gradient editor because it's just really fast to tune, so I can really get the look I'm going for. And then once that gradient, once you've done the remap, You basically just need to combine it back with your hue and your saturation, and then convert it back to RGB so you can use it later along your graph. And this is a super common technique. This is kind of what you use for tune and cell shading a lot of times. So here you can kind of see results from experimenting with different textures to sample from. I ended up going with the bottom right example because I kind of wanted there to be lots of depth in the style I was going for. So even though it's a fixed gradient, there's lots of values I'm using. But I'm done now with my shadows inked section. So let's move on to the next part, the cross-hatching. And this is pretty similar. I'm still using this ramp lighting technique, except now I'm taking in that light value, mapping it to a gradient to control the thickness of our stripes. And because it's cross-hatching, I'm actually doing that for 2 sets of stripes and then rotating them in opposite directions from each other and multiplying it together. So visually, these pieces look like this. So 1 set of lines in one direction, multiplied in the other direction, and I have my cross-hatch results. And you can see I slightly tuned the way the thickness falls off. Just a personal artistic choice there. And the stripes are actually also procedurally generated in ShaderGraph and in their own subgraph. And we'll actually be shipping a number of procedural patterns soon, so look out for those in a future release. But this is like the area I think that ShaderGraph really shines, because taking this idea, you could try a whole bunch of different patterns. You could use that light value to drive a whole bunch of different properties about those patterns. You could try hand-drawn textures. This is really where you get to explore like creative freedom and experimentation to create a new art style. So I'm done now with my crosshatch section. Let's do the next part, my specular highlight with my stippling. So just right away, here's what that specular looks like. Now, I thought the fall off was a little too smooth, so I used this ramp shading technique just to make it a little more of a crisp highlight. And then I multiplied that by some tiling dots, which was part of that procedural patterns pack. I'm also scaling the size of my dots based on the specular fall off, so that means the dot scale kind of increases as it gets closer to the edge of the highlight. Again, artistic decision, because I thought it looked cool. But that solves that part. So let's do the next part, our rim lighting. So there's kind of like 3 parts here I decided was important for my rim lighting. I'm not showing the shader graph, but this is just kind of the steps I went through to progress. So I knew I wanted pretty much a smooth step for now. But then I also only wanted it on the illuminated sides. So to do that, I'm just masking based off that light direction I got from my Get Main Light. I also wanted to mask based on face slope, and this is because I just thought it looked really shiny on very flat surfaces. And that takes care of my rim lighting. Now the coloring was fairly straightforward, just input for a diffuse texture and another color. And there, I have all my pieces done. But let's put it together. So that's what it ends up looking like, which looks complicated. But if we just go back to our very simple breakdown, we can see we're just combining all these pieces we just built up together. So you want to multiply the shadows inked by the cross-hatching. And that's there. Then I want to multiply that output by my coloring, which is next. Then just add our modified direct specular. And then finally add our rim lighting. And that's it. We've made this shader now. So finally, let's make it more usable. Let's make it easy to put across a whole bunch of assets in my scene. So the first thing I did was expose a number of variables from my shader. So you can do this in the Blackboard. But essentially, this means things that would be changed on a per asset basis for each material I create from the shader. So like, there's very obvious ones. They may have different textures or different colors or texture tiling. And then I also exposed the tiling for my cross-hatching and the dots in my specular. And then I exposed a few parameters for tweaking how shiny or rough each of my assets were. Now, something else I leveraged for this project were presets. So essentially, I use these to save different thickness settings for my cross-hatching and my stippling effect. And I named them off of actually the HB graphite scale, because I'm familiar with that from drawing. So there's actually just options for if I was using like a really heavy pencil, you could imagine, or a very fine pencil. Now, one thing to do keep in mind for presets is there aren't partial presets. So if I'm assigning it, I'm overwriting all my values, which if I had a texture assigned, I probably wouldn't want to overwrite that. Either way, I still like creating these and having them in my scene as a reference because it really enforces an artistic consistency across my project. So another important feature, which is coming out in 2019.3, so soon, you're in a beta or alpha if it comes there, you'll be able to use keywords. So keywords are a new feature, but it lets you create true variants in your shaders, and that's really great. It lets you increase scalability, and basically you can have like real feature branching, which is super important for creating performant Uber shaders. So you create them just like you would exposing variables from the blackboard. And I added two in my shader, one that I called Is It Matte? And that turns on and off the specular. And that turns it off completely, which means if it's a matte object, it doesn't do any of the specular calculations. And then I added another one for rim lighting, because I noticed things like the ground, I don't actually need to use any rim highlight on it. So I added another keyword, and that means for assets where I'm using it without the rim lighting, I don't need to calculate any of that logic at all. So here you can kind of see a video of one of the results. So I'm gonna move the light around, and then I'm gonna select the hat and kind of show some of the parameters I exposed and how the keywords would work. So you can see there's an input for textures. Right now, I'm just editing that, how big that specular highlight is, how intense. This is me moving around that rim fall off. And then I'm gonna change the tiling of my cross-hatching to show like all these different effects and looks you can kind of get with that. And then I'm gonna take down, so here's the keywords at the bottom, those two checkboxes. So you can see if it's matte, there's no specular highlight at all. And then I can also just completely remove that rim highlight. And here we have our final results. So I'm just moving the light around to see how it changes. You can And if you want to learn more shader graph tutorials, you can check out learn.unity.com. So right now you can do a 30-day trial of Learn Premium and get a whole bunch of live sessions with Unity experts. And there's a ton of stuff about shader graph specifically on there. And here's the slide to take a picture of. And I'll put it right back up at the end. But basically, the sample project right now, it's on my Git, but it's public. So you all can take a look. And we're hiring, that includes, well, I'll go back to it in a second. And that includes positions in graphics and tech art. So, and I'll leave it up if there's any questions. I can probably take one or two. Yeah. Mm-hmm. So questions about debugging. So there's a few things. They are just shaders, so they should just still work as far as the render doc breakdown. And then there's also additional pieces like there's like these little flags that show up if you have like if something's incompatible. There are little warning messages. So if the shader is not compiling for some reason, it will tell you why. So it will tell you the issue. I think on the shader itself, you can read warnings about it also. Yeah. So because there is not a node right now that grab the lighting data from the scene built in. So that's kind of why we would, for this example, I started with unlit. So the first part was why not use the lit shader and customize the lighting from there? And it's because, well, I needed the output of all that direction stuff to modify it. And there is not a built-in get light basically from the scene. So I had to use my own function call for that. The other question was geometry shaders. There is plans on the roadmap for more features coming up, but I don't have a timeline on that. Tessellation, but it's out from now, so.
So following up on his question.
Yeah, one more question.
I don't know. You showed that you could do it here in this looked like object space. Is there a way to set the cross-hatching and all that kind of thing in world space, and then even taking it further and going into shading it all in normal space?
So I ended up, yes, I used screen space, and that's actually just the way I did the dots patterns. So I also experimented with like UV as well. So yes, you can try out different ways. So the only reason if we go back to the procedural dots is actually where that's coming from, which was forever ago. So
Some other node to kind of get access to the.
Yes. So there is a node in there. Yeah, this guy. So I'm getting position view. Yes, so there's various options to grab data of built-in nodes from the scene. So this was just my decision for this, but yeah, I tried out a few different things, see what I like the best.
Like normal space 1 or a UV space or anything like that you would be able to switch through on the fly. Reason being is that if
you can select view and try, yeah.
That's like, based on this node. What I'm saying is that you would have a node where you could flip between object normal and world space so that you could expose that in the overall shaders.
You could use keywords when that comes out, actually, and then make your own kind of drop down.
Gotcha.
Yeah.
Thanks.
Okay, cool. Thanks.